Hello everyone, myself Swarna Jyothi, working as an assistant professor in computer science and engineering, Madanpalli Institute of Technology and Sciences. Today in this session, I will be presenting the concept of process management, which is an important topic in operating system subject. So under the concept of this process management, today I will be discussing about the concept of process and the process state and process control block, process scheduling, what are the different types of schedulers we have and what is the importance of each scheduler. So these things I will be covering in this session. So coming to the concept of process, so generally we all know an operating system execute a variety of programs. So generally we'll be having some jobs in batch systems, whereas in time shared systems we will be having user programs or tasks. So usually in this session I will be using job and process interchangeably. So take an example. For example, like you have developed one program, like you have written one program in some high level language like C or Python for calculation of some arithmetic operations and some random numbers. So say for example you have developed your program for calculation of multiplication and division on random numbers. So now you have written your code and you have saved your program. Okay, so after that, if you want to see the result, what you have to do, you have to execute that program. So at the time of your program saving, that program will be residing in your secondary memory. So once if you want to execute that program, what internally will get happen means that particular program will be bringing from secondary memory to primary memory, and to that particular program all the necessary resources has to be allocated. So the resources means like CPU and one more thing, all the registers which will be needed by that particular program. Then only that program will start its execution. Okay, so means what? So the program, we can conclude that program as an passive entity which is simply residing without having any without having any program counter and resources. Okay, so simply it is an passive entity. So coming to the process, once the program it starts its execution, that time that particular term process will get highlight. Means what? That particular program is utilizing all the computer resources and what are the registers it is required. So all these things will get allocated to that particular process. So sometimes you can say that the process is it is more than a program code. So sometimes we call it as a text section, and that particular process may have program counter to represent the current activity, and sometimes the process will include the stack which contains some temporary data like function parameters and some return addresses and some local variables. And the process may also include data section which contains global variables, and the process also have heap, so which will be useful for dynamic allocation of memory at runtime process. So by seeing all that, we can conclude that the program is an passive entity which is residing in the secondary storage in the form of executable file. Coming to the process, it is an active entity. So how you will start the execution of your program? So generally with the help of some mouse clicks, or by using some command prompt like that. Okay, so this is way you can differentiate the program and process. So using this process state diagram, I can explain how this process states will work. So whenever if the process is getting created, that time we can say that the process is in new state. So once if the process is admitted, once a process is created and it is admitted, and it is waiting for the processor, so that time we can say that the process is in ready state. So using this process state diagram, I will be explaining how this process state will work. Okay, so once the process will get created, that time you can say that the process is in new state. Once the process is created and it is admitted and it is waiting for the processor, that time you can say that particular process is in ready state. Once the once this waiting process got the processor and it starts its execution, that time we can say that particular process is in running state. So if the process is in running state and it is in execution, so that time, if that particular executing process need any IO or any IO signal or any signal for its execution, that time that particular process will enter from running state to waiting state. After completion of its IO, then that particular process will move from waiting state to ready state. Some other cases, there is some interruption for the executing process. So that time, so interruption means, like, say for example, there is some high priority process which want to execute. So that time what will happen, currently executing process will get interrupt and this currently executing process will be forcibly moved to running state to ready state. So upon interruption, the currently executing process will enter from running state to ready state. So once the CPU or the processor is free, that time this scheduler dispatches the processes from ready state to running state. So these two are the special cases you can consider. And if without having interruption and this IO, or after finishing this interruption and IO completion, so the executing process will get terminate. That time we can say that the process is in terminated state. That one thing you need to remember is, here I have mentioned these two lines. At a time you can have many processes in waiting state and in ready state, but you should have only one process in running state at a time. So this thing you have to realize and you have to remember. Each process is represented in the operating system by process control block. Sometimes we call it as a task control block. So this process control block varies from process to process. So this contains many pieces of information which is associated with that particular process. So what are the different kinds of information we have? So here I have mentioned in this diagram. So here I have mentioned the process control block diagram. So what are the information it is storing regarding particular process? So a process may have its state, so in which state it is present, like new state or running state or waiting state or like that. Process state information this process control block will have, and it have like what is the next instruction it is going to execute. That thing will be represented using this program counter and the CPU registers information. So as I said earlier, if any program want to execute, that time it utilizes some CPU registers like accumulator and so like some general purpose registers like that. So it needs some registers. So what are the CPU registers we have? Like that, the CPU registers information it will be having, and sometimes we will be having some scheduling information also, like what is the priority of that particular process and the scheduling queue pointers information. All this information we will be having in CPU scheduling information, and how much memory is allocated to the particular process, like base register value, limit register value. So all these information, page table information, all this information you will be having in memory management information section. And sometimes you will be having how much amount of CPU that particular process has been used, and what is the time, what is the clock time we have for that particular process, and what is the time limit. All this information you will be having in accounting information section. And for each process there will be some like IO devices for each process. For each process, sometimes it may require some IO devices. So what are the IO devices that are allocated to that particular process, and what are the open file list of open files? All this information you will be having in IO status information. So here in diagram I have mentioned the structure of a process control block. So all these pieces of information you can see in the process control block. So you can say, like, this process control block acts as an repository for a process. Like, you can have all the information regarding one particular process, and you need to remember this PCB information vary from process to process, and this will be unique for each process. So the next concept is process scheduling. So before discussing this process scheduling concept, as you all know, the objective of multi-programming is we need to maintain one process all time for the CPU to maximize the CPU utilization. And the objective of this time sharing systems is we need to switch the CPU among the processes so frequently so that the user can interact with the running process in a easy way. So to meet these two objectives, like maximizing the CPU utilization and for switching up these processes on CPU, so this process scheduler will help. The next concept is process scheduling. So before having discussion about process scheduling, as you all know, the objective of multi-programming is we need to utilize the CPU time as much as possible. So, and the objective of this time sharing systems is we need to switch the CPU between processes so frequently so that user can easily interact with the running processes. So for that, to meet these two objectives, process scheduler selects among available processes for next execution on CPU. So generally, we all know, like, before discussing the process scheduling concept, as we all know, the objective of multi-programming is to have at least one process in execution for the CPU so that you can utilize the CPU time as much as possible. And the objective of time sharing system is the switching of CPU among the processes in frequent manner so that user can easily interact with the running processes very easily. So further, process scheduler selects among available processes for next execution on CPU. Generally, for single user system, there will never be more than one process in execution. So if there are more than one process, then all those processes must be in waiting state. So to maintain all these processes, operating system is going to maintain scheduling queues of processes. So all the processes which are entering into the system, all those will be put into the job queue, and the processes which are present in the main memory and are waiting for the processor, those will be kept in the ready queue, and the set of processes which are waiting for the IO devices, so those will be kept in the ready queue, device queues. So likewise, you will be having different types of queues available in the operating system. So using this queue diagram, you can get to know how this scheduling will get happen. So generally, a new process will be kept in the ready queue, and that particular process will be waiting here until it selects for the execution. So once that particular process get the CPU, and it will be in the running state. So in the running state, several events may occur. So here I have mentioned some events. So that particular running process may need some IO signal or an IO device operation. So that time the executing process will be put it into the IO queue, after completion of that IO request, that particular process will be moved from IO queue to ready queue. So likewise, if that particular executing process require, or that particular executing process need to create any sub process using fork system call, and it want to wait for the completion of the sub processes execution, so that time it will be in waiting state, or upon the interruption, that time the executing process will be entering into the waiting state or in waiting queue. After completion of this interruption, it will be entering into the ready queue. So likewise, that process will be migrating through several queues in its lifetime. So we have different kinds of schedulers. So why we need to have different kinds of schedulers? What is the importance of scheduler? So as we discussed earlier, so any executing process will be migrating over several. The next concept is schedulers concept. So what is the importance of scheduler and what are the different types of schedulers we have? So the importance of schedulers is, as we have seen earlier, the running process or the executing process will be migrating through several queues. So the scheduler will be selecting particular process from the scheduling queue, from the scheduling queues, and it will be allocating to the CPU. So for that we will be having three different kinds of schedulers available in our operating system: short-term scheduler, long-term scheduler, and medium-term scheduler. So how these schedulers will work? The long-term scheduler will work. So or you can coming to the concept of schedulers, as we have seen earlier, executing process will be migrating through several scheduling queues. So the operating system has to pick the process. Coming to the schedulers concept, as we have seen earlier, the executing process will be migrating through several scheduling queues. So the scheduler will be picking the process from the scheduling queues and it will be allocating to the CPU. So for that, in our operating system, we have three different kinds of schedulers: long-term scheduler, short-term scheduler, and medium-term scheduler. So often in batch systems, what will happen? So in batch system, like the system will submit more processes than execution. Often in batch system, more processes are submitted than execution immediately. So all those processes will be residing into a, often in batch systems, more processes will be submitted than execution immediately. So all those processes will be spooled to a mass storage device, and this long-term scheduler is going to pick the processes from that pool, and it will be bringing that particular process from secondary memory to primary memory. And this short-term scheduler, often we call it as a CPU scheduler. So what that scheduler, how it will work? So that short-term scheduler will be picking the processes from the short-term scheduler picks the process which is ready to execute, and it will allocate the CPU for the execution. So how you can differentiate this long-term scheduler and short-term scheduler? Based on the frequency, this long-term scheduler plays a major role, or it is a root cause for the multi-programming. It will maintain, this long-term scheduler maintains the, or it controls the degree of multi-programming. So if you have more number of processes, how you can differentiate this long-term scheduler and short-term scheduler? So based on the frequency, so how much frequently these two schedulers will work? So long-term scheduler controls the degree of multi-programming, and this short-term scheduler always works in a frequent manner. So this long-term scheduler will be picking the processes from the secondary storage, and it will be bringing them into the primary memory. And this short-term scheduler will be picking the processes from the ready queue or from the ready queue, and it will be assigning to the CPU. The importance of medium-term scheduler is it can be added if the degree of multiprogramming needs to decrease. This medium-term scheduler remove process from memory and stores on disk and bring back in from disk to continue execution. Often we call it as a swapping. So here in diagram I have mentioned. So as I said earlier, new process will be kept in the ready queue. Once it allotted to the processor, it will be in execution state. If the degree of multiprogramming is more, that time we will be swapping out the executing process and we will be keeping in the ready queue. The importance of medium-term scheduler is, so it can be added if degree of multiprogramming needs to decrease. Why degree of multiprogramming needs to decrease? If you have more IO bound processes or if you have more CPU bound processes, that time it will be difficult for the CPU. Medium-term scheduler can be added if degree of multiprogramming needs to decrease. It removes processes from memory, stores on disk, bring back from disk to continue its execution. We often call this concept as swapping. So with the help of this diagram, you can easily understand how this will work. So generally a new process will be keeping in the ready queue, and once this process will get this CPU, so it will be in execution. If you want to decrease the degree of multiprogramming, that time we will be swapping out the process from CPU, and here you will be having partially executed swapped out processes. Later, after some time, we will be swapping into the ready queue again for its execution. So likewise, this medium term scheduler will work. So all these things I have taken from this references. Thank you. That's all for this session.